Exactly. Okay. What was weird is they did the exact opposite of what you'd think. So you would think that adding h would move it to the right h, subtracting h would move it to the left. It doesn't. It does the exact opposite. And then we talked about a couple of other changes. This is a vertical flip. It takes that same shape and flips it upside down. This is a vertical stretch. It makes the graph twice as tall as it used to be. And this is a vertical shrink. It makes it 1/4 as tall as it used to be. Again, it doesn't make it wider. Okay, it makes it shorter. Okay, and then we talked about what would happen if we put a negative in front of this. It would make this wide shape, same as that blue one right there. It would just open down because it's been vertically flipped. Okay, so we talked about the difference between vertical changes. These are all vertical changes. Notice that we make the shape, add, make the shape, subtract, make the shape, times it by 3, make the shape, times it by -2. Those are all vertical changes. Okay, if we change the x before we square to make the shape, then it moves it to the left or to the right. It makes a horizontal change, in other words. And then we finished off by graphing the two of these. These have all the transformations that we're talking about. So, whoops. Didn't see what happened there. Good, we're still recording. So this change, we went up 2, we went to the left 3. This vertically flips it and vertically shrinks it. So we know where the vertex is, and then from the vertex, we can just go over and down however many we need to get to another point on the graph. Okay, are there any questions? Okay, you'll notice that on this page, we didn't do a single XY table, not one. Okay, but I think toward the end there, we did figure out what this graph looked like and then picked one of these and plugged it in, because if this XY pair is on the graph, it better work when we plug it in the equation, right? So watch what happens if we plug in a -5. If I plug in a -5, that's -2. Square that. Square -2, I get 4. Times it by a -1/2. Half of -2, 1/2. Sorry, -1/2 times 4 would be 2, so we got a -2 there, and then add 2, so we get 0 right there. Okay, so that is a point on the graph. It works in the equation, and we got that not by plugging in points, but by thinking about the pattern. Okay? All right, so we left off right here. So we talked about how when we graph a line, we put it in a graph-friendly form like slope-intercept form. Okay, the graph-friendly form for a parabola is called vertex form. And this is what vertex form looks like right here. You need to recognize this. We're going to be putting them in this form quite a bit. Once we have it in this form, we can tell lots of stuff about it. The most important thing to start with is the vertex. So if we moved this, does this move it to the right or to the left? The h. Moves it to the right, so that would be at h. And this moves it up, so the vertex is at hk. Okay, the axis of symmetry, if the vertex is at hk, then the axis of symmetry is always going to be x equals the x coordinate of the vertex. So it's always going to be x equals h. How do we tell whether it opens up or down? Okay, if a is positive, or in other words, if a is greater than 0, it opens up. If a is negative, or in other words, if a is less than 0, it's going to open down. Okay, if it opens up, so if we've got a parabola that looks like this, does it have a maximum or a minimum value? It has a minimum. It has a smallest value right here. It occurs at the vertex. If it opens down, then it's going to have a maximum. Okay, either way, whether it opens up or down, the maximum or minimum always occurs where? At the vertex. Okay, and we usually say it this way. We usually say either the max or min is, we give it a y coordinate. Okay, so we say the max or min is whatever k is, and it occurs at h. So the max is y equals k, and the min is, and it occurs at x equals h. Okay. Any questions? Okay, then we're going to graph this one really quickly using these ideas. So where is the vertex for this particular graph? Careful. Opposite of this, so that's -2, same as that. So it's at -2, -1. So back 2 and down 1. So we're right here. There's the vertex. Okay, what's the axis of symmetry? X equals -2. Once you find that x coordinate of the vertex, there's your axis of symmetry. So I'm going to draw this vertical line right here. That's our axis of symmetry. Opens which? Up or down? Opens up. You can tell that because that's got a 3 right there. Okay? It's been vertically stretched by a factor of 3. So it's 3 times taller than it used to be. So this should be a pretty steep, pretty big graph. Is this going to have a max or a min? It's going to have a minimum because it opens up. Okay, now I'm going to go ahead and sketch this. We want to label the axis of symmetry, so that's x equals 3, or sorry, x equals -2. We want to label the vertex. Vertex is at -2, 1. Sorry, -2, -1, thanks. Good thing I got John here. Okay, and Sid. Normally I go over 1 and up 1. I'm going to go over 1 and up how far? Careful. Up 3. So normally we go over 1 and up 1 squared, so we go up 1. We're going to go 3 times as far, so we're going to go 1, 2, 3. So we're going to be right there. Now let's go ahead and label that point while we've got it. If I was at -2 and I went to the right 1 unit, I'd add 1 to the x coordinate. So that's going to be -1. If I was at -2 on the y-axis, sorry, -1 on the y-axis and I went up 3, where does that put me? That puts me at 2. Okay, I'm going to go over 2. Normally I'd go up 4. I'm going to go up how far? 3 times as far as 4, so that's going to be 12. So I'm going to go over 2 and up 12. So that's going to put me at right there. Now, with a nice piece of graph paper like this, it's pretty easy to tell where we are. If we were at -2 and we went to the right 2, we get to 0. And if I was at -1 and I went up 12, where does that put me? That puts me at 11. Okay, any questions? Sure? No questions? Okay, let's do this one right here. If I go back 1, I normally go up 1 squared. I'm going to go back 1 and I'm going to go up 3. Now here's the cool part about this. If you figured out the y coordinates for these guys right here, the y coordinates for these 2 points should be a piece of cake, because remember, it's symmetric. It's called an axis of symmetry for a reason. If this y coordinate is 11, what should this one be? Should also be 11. If this one is 2, this should also be 2. And again, if we started here at -1 and went up 3, that would get us to 2. If I was at -2 and I went to the left 1 unit, what's my new x coordinate? -3. Okay, and this one? -4. Please take a look. -4, -3, -2, -1, and 0. There are your 5 key points. Look at the y values. 11, 2, -1, 2, 11. See all the symmetry there? Any questions? Okay. All right. Let's take a look at a couple more then. And let me just say, these are similar to the ones that are on your assignment. Some of these may be on your assignment. Whoops, I forgot to graph this, didn't I? And what else did I forget to do? Okay, so this is going to have a min of -1, and it occurs at x equals -2. Okay, so right there, there's our minimum. A minimum value of -1, and it occurs at x equals -1. Okay, there's a big difference between saying what is the max or the min and where does it occur. Okay, so on each of these problems, label 5 key points on the graph, draw and label the axis of symmetry, state the max or the min, okay, that's the y coordinate, and where it occurs, that's the x coordinate. Okay, now, I had somebody, and I have this almost every single year, somebody will come in and they'll say, hey, my teacher showed me a quick way to figure this out if there were fractions. Okay, Zach, you're guilty? Okay, Zach's guilty on this one. There are quick ways to figure them out if they're fractions. You have to learn a different rule for every fraction, whether it's 1/4 or 1/2 or 1/3 or something like that. This is kind of a fraction right here. Okay? It's much better, those tricks, they do get you the right answer, but it's more important that you understand why they produce that graph. Okay? And why those would be nice numbers to plug in. So if you can explain why they're nice numbers to plug in, or why you'd go over 6 rather than going over 2, that's fine with me. Okay? But you better be able to explain it. So let's take a look at this one right here. We just need to graph this. What's the only thing that's been done to this? Stretched it vertically, right? Made it taller. Because this is 1.5, right? So my vertex is still here. My vertex is still 0, 0. There's our vertex. I'm still going to have an axis of symmetry of x equals 0. And then I'm going to go over 1. And how far up am I going to go? I normally go up 1. I'm going to go up 3/2 or 1.5. Now everybody watch, please. There's my point right there. I went over 1 unit and I went up 1.5, or I went up 3/2. The other problem I have with not understanding and doing the problem this way is that when we get into the next chapter and we're doing exponentials and logarithms, okay, there's no easy fraction rule for those. Okay? It's much better that you understand what we're doing here is we're vertically stretching this. We're either making the y-coordinates taller or shorter than they used to be. In this case, I'm making them taller. Okay? So now I'm going to go over 2. Normally I'd go up 4, but what's 4 times 3/2? Yeah, cancel there. 2 times 3, that's 6. So I'm going to go over 2 and up 6. So this coordinate would be 2, 6. I've got the same points symmetric on the other side. Here's what the graph looks like. That would be a 6. That would be a 3/2. Because the axis of symmetry is 0, this is going to be -2, 6, and this is going to be -1, 3/2. Okay, what's the only other thing we need to do here? Okay, min of what? 0 occurs at x equals 0. Okay. Any questions? Okay, next one. Sarah Brown, what did this do to the graph?
Moved it.
Okay, so that's left if I'm reading correctly. Okay, left 4. So where's the vertex? -4, comma, didn't go up or down, so it's just -4, comma 0. So here's our vertex. So the vertex would be -4, comma 0. Here's the axis of symmetry, x equals -4. Did we change the shape at all? Nope. So we're going to go over 1, up 1 squared, over 2, up 2 squared. And then we're going to do the same to the left. Left 1, up 2 squared. Left 2, up 2 squared. Now, when you take the quiz in just a little bit, you're going to need to graph them like this, label the points. This is exactly what the quiz is like. To the right one, -3. To the right one more, that'd be -2. I went up 1 from 0, so that's a 1. I went up 4 from 0, so that's a 4. And then take a look at the symmetry here. If I went back 1, that would be -5, and this would be -6. Any questions? Can you do them that fast when they're nice whole numbers like this? Okay. Max or min? Min of 0 at x equals -4. Any questions? Okay, Chrissy, what does this do? Okay, that's a vertical flip. And Elaine, what does this do?
Vertical rise of 2.
Okay, a rise of 2 or vertical shift. Okay, vertical shift of 2. So we're going to go up 2. So we're going to take this and we're going to vertically flip it and we're going to move it up 2. So where's the vertex? Okay, didn't change the x's at all, so it's still at 0. We went up 2, so it's going to be at 0, 2. So we're right here. Then I'm going to go over 1 and up or down? Down, because we vertically flipped it, right? That putting a negative in front of it instead of opening up, instead of going over and up, we're going to go over and down. So we're going to go down 1, over 2, down 4. And then we're going to do the same thing on the other side. So here's our axis of symmetry of x equals 0. Here are the points. I'm not going to take the time to label those. You should be able to label all 5 of those relatively quickly. Max or min? Max of what's the value? 2. Okay. Occurs at x equals 0. Okay. Everybody watch, please. Okay. You'll notice once I find the vertex, in order to figure out what the max or min is, all I need to do is know whether it's up or down. So this has an x coordinate of 0 and a y coordinate of 2. That means the max is 2 and it occurs at 0. Once you have these, that's the location of the max or the min. So notice on this one right here, I had the vertex at -4 is 0, so that means the minimum is 0 at this x coordinate. It's that simple. The max or the min will always occur at the vertex, so once you know where that is, you don't even have to graph it in order to figure that out. So for example, take a look at this one right here. This is number 52. Without graphing, find the vertex, the axis of symmetry, and the max or the minimum value. So vertex, opposite of this, same as that right there. Axis of symmetry, x equals the x coordinate. Okay, now you do have to think, does this open up or down? Opens up. If it opens up, it's got a minimum. Where does the minimum occur? At the vertex. So the minimum is -10, and it occurs at x equals 1. Got it? Okay, would you graph this one right here? Would you graph 44? Go ahead and do 44. Label the axis of symmetry, label the vertex, get all the points and everything. Parker, what's the x coordinate of the vertex? 44. 2. Susie, what's the y coordinate of the vertex? -4. Okay. And you can tell that because this is going to move the graph down 4. That's going to move it to the right 3. And the only other thing that happens here is what, Sarah? Oh, yeah, sorry. Right 2. Sarah, what's the only other thing that happens here? Okay. So this tells us it opens down. Hasn't been stretched or shrunk at all. It's the same shape, it just opens down. Okay? McKay, what's the axis of symmetry?
X equals 2.
X equals 2. Okay. And John, does this have a max or a min? Has a max. Christopher, what is the maximum value?
-4
At x equals 2. Okay? So if we graph this, we're at 2 and -4. So we're right here. We know it opens down, so we're going to go over 1 and down 1. Over 2 and down 4, so that's going to put me about right there. And then I've got these other points over here that are symmetric. Here's my axis of symmetry. Might want to draw that first. Our vertex is at 2, -4. And then I want to label these other guys right here. Yeah.
How come you labeled it x equals 0?
Oh, sorry. Because I wasn't thinking. X equals 2. Let's see. Emily, what is this point right here?
I got
3, -5. Sounds good to me, right? Okay. Ingrid, what's this point right here? This one right here. Okay, -8 is the y coordinate, but we went over 2 from 2, so that's going to put us at 4, and then we went down 4 from -4, that put us at -8. Does that make sense? Okay. Okay, what if we want this one right here, Jared?
That's 1, 5.
1, -5. Okay, and then we want this one right here. Brienne, how about this point right here?
Is that 0, -8?
Excellent, 0, -8. Okay, any questions? Okay, last one I want to look at really quickly. It says, write an equation for a function having a graph with the same shape as 3/2 x squared, but with the given point as the vertex. So this one has a vertex at 0, 0, at the origin, right? How would we make this graph move over 1 to the right and then up 3? Don't say anything out loud, just write it down. It's got to have a 3/2, right? How do we make something move up 3? Okay, add 3 outside the parentheses, so on the end. How do we make it move to the right 1 unit?
-1.
Okay, so we're going to do x minus 1. We're going to slow that down by 1 unit. It's going to make the same shape, it's just going to make it 1 unit later than it did. Okay? If we put a +1 there, that wouldn't quite be right because that would move it to the left. It would make it 1 unit sooner, not 1 unit later. Okay, any questions? Okay, let me just point out a couple things. Hopefully you did a bunch of these. Okay, you didn't have to do them all, but hopefully you did enough, you got a flavor. Hopefully you're rock solid on these, and hopefully the stuff that we did today. This is a big deal, putting this in vertex form. Okay, we're going to be doing that quite a bit in this chapter. On the last page, there are several graphs there. I think there's 6 on there, and let me show you where you can get other copies of those. If you go to the website here and we open up chapter 8, it'll open up here, and under 8.6, I've got a bunch of stuff for 8.6. I've got the lecture notes, and then it's got graph paper with 4 big coordinate axes, 12 small ones, and then I think I was going to load, maybe I didn't load another one on there. Let's see what this one looks like. I've got another one that has like a grid rather than the dots here. So if you need to download any of those, you're welcome to. And I will get another one uploaded that has, let's see, did I get it on here? I don't think I did. I've got another one that just has 2 nice big axes on one sheet. So there'd only be room to put 2 of them on a page, but plenty of room to show your work, count squares, all that sort of stuff. Okay, any questions? Okay, we're going to have a quiz in about 15 minutes, okay? So if you've got a question, if you're not clear on something, make sure you ask before then. If you want to work out of the book and get the book work done, that's fine. If you want to work in Math Excel, that's okay, but we need to be done about right around 10 after, okay?